These are the video notes for Objective 5A, Arithmetic, Sequences, and Series. So the first question in the notes is, what is an arithmetic sequence? And an arithmetic sequence is any sequence of numbers that demonstrate a constant addition pattern. So an example of that would be 1, 2, 3, 4, etc., because each number is one more than the one before it. A non-example would be 1, 2, 4, 7, ... Although I'm adding in each of these steps, this time I added 1, and then I added 2, and then I added 3. So this is not an arithmetic sequence because the addition is not constant. Another example of an arithmetic sequence would be 4, 2, 0, -2, ... in which case I am subtracting 2 each time. And another non-example would be 1, 2, 4, 8, ... In this one, I am multiplying by 2 constantly instead of adding or subtracting. Sequences can be any types of numbers, so these examples I've chosen are integers, but I could have used decimals or fractions, and it wouldn't change whether the sequence was arithmetic or not, as long as there is an adding or a subtracting pattern. Now, with arithmetic sequences, because this pattern in addition and subtraction is constant, it can also be referred to as the slope. These functions end up being linear since the distance between each point is the same every single time. Well, if these functions are linear, it means that we can use a linear type equation to model an arithmetic sequence. So our linear equation will look like this. AN stands for the nth term. I like to call it any term. A1 stands for the first term. D stands for the common difference, also known as the pattern. And N stands for the number of the term. So if we were talking about the fifth term, N would be 5, but if we were talking about the 101st term, N would be 101. So we want to find the nth term of a couple different examples of arithmetic sequences. The first example, we want to find the 10th term of a sequence that goes 1, 6, 11, and 16. And so one option, because this is a pattern, is that you could continue to follow the pattern. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and then 10th term. What is the pattern in this sequence? Each number is 5 more than the number before it. So the next number would be 21, 26, 31, 36, 41, and finally the 10th term being 46. The other option is to use this idea of repeated addition, aka multiplication, and the arithmetic sequence formula. So the formula is the first term plus the common difference times how many times you have to add that difference to get to the 10th term. Well, if you want the 10th term, you're going to have to add 5 9 times, which is why we have an n minus 1 in the problem. To find the 10th term, you repeat the pattern 9 times. To find the 50th term, you would repeat the pattern 49 times. And so we find that an is equal to 45 plus 1. Make sure you're using a calculator to find these values because it's very tempting to do 1 plus 5 and then times 6 and break the order of operations. So it's better off if you allow your calculator to do the simplification of the numbers for you. Let's repeat this for example 2. In example 2, we're asking to find the 75th term, and that's because I don't want you expanding the sequence. 75 is way too many terms to not use a formula. Now it says the first term is -4, and I like to write it in notation. So I write A1 equals -4. and it says the common difference is 2. Let's plug the values we know into the formula for arithmetic sequences. A75 means the 75th term. Now this 75 is not a numerical component of the problem. We're not going to add 75, we're not going to subtract 75, we're not going to mess with the 75. Then A1, they told us, was -4. The difference, they told us, was 2. And N is 75. Again, use your calculator to complete this problem. We get that the 75th term is 144. Example 3 asks us to find the 16th term of the sequence, and then it really throws us through a loop because it doesn't tell us any of the information that we need for our formula. There are a lot of ways to solve this problem. We can logic our way through and use the 4th and the 8th term to figure out the 16th term, which is more than welcome. But for the video notes, I'm trying to show you how to use the formulas to find the missing terms. So we have 2 pieces of information. We're going to make 2 equations. That's a system of equations which we're going to use to solve for the 16th term. Here we have that the 4th term is 6. So we can say 6 is equal to an unknown first term plus an unknown common difference times 4 minus 1. Simplifying, we get 6 equals A1 plus 3D. This is our first equation, and we're going to repeat that process with the 8th term being 8. 8 equals an unknown first term plus the common difference, 8 minus 1. 8 equals A1 plus 7D. Here are the 2 equations that form a system of equations that we can use to find the first term and the common difference. So you're going to have to decide whether you would rather do substitution or the elimination method, but let's write these 2 together as a system of equations. So we have 6 equals A1 plus 3D, and 8 equals A1 plus 7D, and we can use the elimination method or the substitution method, although I think this one lends itself to the elimination method. In order to eliminate the A1s, I need to subtract one equation from the other, so I'm going to make the first equation negative, and I get 2 equals 4D, which means that D equals 1/2 or 0.5. Plugging that back in, I get 6 equals A1 plus 3 times 0.5, which is 6 equals A1 plus 1.5, or A1 equals 4.5. That's a lot of calculation to find this information, and it still doesn't answer the question. What is the 16th term? So we write A16 equals A1 plus the common difference times N minus 1. Use your calculator to find out the 16th term. We get that the 16th term would be 27. Another option, instead of using a system of equations, is to use slope to find the common difference. So we have the 4th term is 6 and the 8th term is 8. Since this function is linear, we can do output minus output divided by input minus input, which tells us our common difference is 1/2. And so we wouldn't need a system of equations to solve for A1 and D if we already knew what D was. So keep that in mind in case you want to find other ways to solve the problem. You're more than welcome to, since arithmetic sequences are just about patterns. This concludes part 1 of the video notes for Objective 5A, where we focus on arithmetic sequences and the explicit formula for an arithmetic sequence.